Alright, we're back with 9.6 video 2. We're talking about asymptotes and limits and their connection. First thing I want to talk about is are limits at a point. Okay, vertical asymptotes are limits at a point. So remember I asked you to factor this, factor and simplify. You should have gotten 3x minus 1 and I got x plus 2 all over x plus 4 and x minus 2. Alright, obviously here nothing cancels. Okay, nothing cancels. But remember, when I have a simplify, look at the domain of my function, this tells me I'm going to have two vertical asymptotes. Remember, our vertical asymptotes are when there's nothing simplified, nothing can be canceled, or if everything else is canceled, when it's completely simplified, I look at my denominator. What can x not equal? X cannot equal -4. X cannot equal 2. So I'm going to plot those here, talk about our connection. So my vertical asymptote at 2 and -4. Alright, so when thinking about vertical asymptotes, if I think about my limit as x approaches -4 from the left, my answer, or if I think about the limit as x approaches -4 from the right, that should be a plus, not an h, from the right hand side. My potential answer to both of these two can either be in the form of positive or negative infinity. Because think about your function. As my function is approaching this, it's going to go up, up, and away, or it's going to go down, down, down. Okay. Similarly, if I think about 2, I could have the same problem, the same result. I can have the same exact thing. Okay, it can be positive or negative infinity. Well, how do I determine the limits at those points from positive or negative infinity? Well, the thing I want to do is I want to think about my graph. So when I think about the graph of this function, well, at positive 2, let's talk about -4 first. At -4 from the left, so -4 from the left, what's my function doing? Oh, it's going up, up, and away, so it's going to positive infinity. At -4 from the right-hand side, all right, what's my function doing? Oh, it's going down, 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 so it's going to negative infinity. All right, 2 from the left, as I approach 2 from the left, my function goes down, so it's negative infinity here, and 2 from the right, my function goes to positive infinity. Vertical asymptotes, I can tell that I have a vertical asymptote if this is true on a function. If the left and the right hand limits are positive or negative infinity, that tells me that there is a vertical asymptote. Or a vertical asymptote tells me that the limits at that point can be positive or negative infinity. It goes both ways. Okay. We also, if we're using the same function here, all right, we also want to look at, well, I had those at positive 2 and at -4, I had those vertical asymptotes. I also want to think about our end behavior asymptotes and our limits at infinity. So connecting what we just talked about earlier in this video. Well, if we think about our end behavior asymptotes and our limits at infinity, if we think about this function is even heavy, right? This is an even heavy function because when I factored here, okay, I completely factored, nothing simplified. Well, that tells me that degrees are the the degrees are the same. Since my degrees are the same, I take the leading coefficients. Okay, my leading coefficients are 3 over 1, so I'm going to have a horizontal asymptote at y equals 3. When we think about what we talked about earlier, all right, if I have a horizontal asymptote, if there's a horizontal asymptote, then the limit will approach that number. Well, let's think about that. As the limit goes to positive infinity, or the limit as x approaches negative infinity, most of the time, I don't like saying all the time, are limits of positive and negative infinity can be an actual number. All right. When can they be a number? They can be a number when I have a top-heavy function, when I have an even-heavy function or a bottom-heavy function. Otherwise, what would they be? If I had their slant asymptote, the limits as x goes to positive or negative infinity are going to be positive or negative infinity. So there's a relationship between the MBA asymptotes and the limits at infinity. If we think about this case, well, if we look at the graph of our function, I have something that looks like this. So I have something here. This is a rough sketch here and there. Well, as x goes to positive infinity, y is approaching 3. As x goes to negative infinity, y is still approaching 3. Alright, y is still approaching 3. These don't have to be the same. Remember, I could have positive and negative infinity here. Okay, these don't have to be the same. Okay. When would they be the same? When there's a horizontal asymptote, these will most likely be the same. I don't like to say always because you're going to find a case where that's not true. Alright, so these two slides are meant to connect our asymptotes to our limits. Okay? And we'll have our next video will tie everything together. It's a great one.